Have you ever stopped to think about what's really going on when you hit send? I mean, there's this secret, super high-speed conversation happening between all your devices, pretty much all the time. So today, we're going to pull back the curtain and figure out how they actually talk to each other.
I mean, really think about it. You tap a button on your phone, and just seconds later, a photo you just took pops up on a screen that could be thousands of miles away. It totally feels like magic, right? But it's not. It's actually a perfectly structured, lightning-fast conversation, and we are going to break down exactly how that works.
Okay, so first things first. Before any devices can talk, they've got to be in the same room, so to speak. And in the digital world, that room is what we call a network. You can pretty much think of it like a giant group chat for all of your gadgets.
So what is a network at its core? It's really just two or more devices linked together. That's it. Now, that link can be a physical one, like an old-school Ethernet cable, or it can be wireless, using radio waves, which is what your Wi-Fi is. And the whole point, the entire reason for it, is to share stuff, information, and resources.
All right, so our devices are all in this massive digital group chat, but how do they actually have a conversation that makes sense? Well, it turns out that every single digital interaction, I'm talking everything from a simple text message to streaming a huge movie, is built on a foundation of 5 key components.
And here they are. You've got the message, the sender, the receiver, the medium, and the protocol. If you get these 5 things right, you get successful communication. It's that simple. So let's break each one down real quick. First up, we have the message. This is pretty much the what of the conversation. It's the actual stuff being shared. That photo, the text, the email, or that cat video you're about to send.
Okay, next, you obviously need the participants in the conversation. So you have the sender, that's the device kicking things off, like your phone. And then you have the receiver, the device that's getting the message, like your friend's laptop or maybe a server out there in the cloud. Yeah, pretty straightforward.
Then there's the transmission medium. This is all about how the message travels. It's the physical path it takes to get from A to B. A great way to think about it is like the air that carries your voice when you speak. For our devices, though, that path could be a copper cable, a super fast fiber optic line, or just the invisible radio waves that make up your Wi-Fi.
And now we get to what is, I would argue, the most important piece of this whole puzzle, the protocol. A protocol is just a shared set of rules. It's the common language that both the sender and the receiver absolutely have to agree on. Because without it, you don't have a conversation, you just have digital noise.
This quote nails it perfectly. Think about it. It's just like a human conversation. If your phone tries to send a message using one set of rules, but your friend's phone is listening for a completely different set, well, nothing's getting through. It's just gibberish. They have to be speaking the same language, like HTTP for websites or SMTP for your emails, for the conversation to mean anything at all.
Okay, so we've got our 5 essential components down. But, just like with people, not all conversations are the same. Digital chats can have different flows, too. You could call them conversational styles.
There are basically 3 main styles to know. First, you've got simplex. That's a total one-way street. Data only flows in one direction, like when you type on your keyboard and it goes to your computer. Then there's half-duplex. The best example here is a walkie-talkie. You can talk, then I can talk, but we can't talk at the same time, Over. And finally, full duplex. This is just a regular telephone call where we can both talk and listen at the exact same time. And most of our modern communication is definitely full duplex.
So we've covered the what, the who, and the how of the conversation. But what language are these devices actually speaking to each other? This is where we get to the real secret, the fundamental core of all digital information.
Just take a second to let this sink in. No matter how complex a message seems, whether it's a 4K movie, a beautiful symphony, or just a simple lol text, every single piece of that has to be translated. It all gets broken down into one fundamental, universal language that literally every computer on the planet can understand.
And what is that language? It's binary. That's it. It's all just zeros and ones. A 0 basically means off, and a 1 means on. Every single thing you see and do on a computer, at its absolute most basic level, is just a ridiculously long sequence of these simple on and off signals.
But wait a second, how can simple zeros and ones create something as complex as a picture? Well, any image is just a grid of tiny little dots, right? We call them pixels. And for a simple black and white picture, we can just assign a value to every single one of those pixels.
So, let's just say a 1 represents a black pixel and a 0 represents a white one.
If you arrange all those ones and zeros in a grid, a pattern starts to emerge. Suddenly, you're not just looking at a bunch of numbers anymore, you're looking at an actual image built from the simplest language imaginable. And that right there is the key. All digital data is just a pattern.
And this idea applies to literally everything. Text is just a bit pattern. The letter A, for example, is nothing more than the binary code 0110001 to a computer. String enough of those codes together, and you get your .txt or .pdf files.
It's the exact same story for images. They're just bit patterns, like we just saw. And those patterns get stored in the file formats you use all the time. JPEGs, PNGs, GIFs, you name it. Audio? Just a series of binary numbers representing sound waves. Video? That's just a whole bunch of image patterns played one after another, super fast. It's all of it, just zeros and ones, all packaged up into formats we know, like MP3s and MP4s.
So that brings us to a really interesting final thought. If that photo you sent to your friend, or that song you wrote, or even just that simple message you typed, if it all just boils down to a massive, long string of ones and zeros, then what is it exactly that makes that specific pattern uniquely yours? Kind of makes you think, doesn't it?